Welcome back. In this quick video, we'll be looking at how to compare objects in Python. Let's create a simple class student, and let's say it's an empty class. Let's create a couple of instances of it. Student1, and let's say student2 is equal to student as well. Are these two students equal? How do you define that? Right now, these classes don't really have any content as such, right? So if I do an ID of student1, it gives you an indication of where it is stored in memory. And if I do ID of student2, you can see that it's returning 768 and this is returning something else. And these two are different objects. So these two are completely different objects. So when I do something called is this is one of the ways you can compare objects. Student1 is student2. What we are really comparing is where they are stored. Is it the same object? Is student1 the same object as student2? That's what is compares. Is checks if both of them are the same object. If both of them are different, then this returns a false. Let's say student3 is equal to student1. What would happen now? So I'm assigning student3 the same object which is referred to by student1. So if I do ID of student3, what would it have? It would have the same ID as student1. So if I do student1 is student3, what do you think will be the output? It's true because both of them are the same object. In Python, you can use is equal to check the content of an object. So student1 is equal to student2 is typically supposed to check the content of the object. So if I say student1 is equal to student3, this would return true. Is equal to student2, this is returning false. One of the things is this class does not have any content really. I mean, there's nothing present inside the class as of now. But the default implementation of is equal to typically uses is directly. So whenever you don't provide an implementation for is equal to, what happens is by default is used. But sometimes you would want to provide a implementation for is equal to check the content of the object. What kind of situations? Let's create a simple example right now. Let's create the student class again, but this time let's have a constructor. So I'll say def underscore init underscore and pass in self and comma id. So I'll want to pass an id and let's say self.id is equal to id. So we are creating a simple class which has a constructor accepting an id. So let's now update the definitions of our students. I'll say student1 is equal to student of 1. Student2 I'll say is student of 2, and I'll say student3 is equal to student of 1 and student4 is equal to student 1. If you look at these objects, student 4 and student 1 are referring to the same object, right? So if I do ID of student 1 and ID of student 4, it would return the same value. So student 1 is student 4. Is that right? Yes, that would return true. However, if I say student 1 is student 2, false. Student 1 is student 3, what do you think will be written? False, because those are different objects altogether. However, one of the important things that you would see here is student 1 and student 3 have the same content, right? They have ID of 1, student with the ID of 1. So what do you think will happen when I say student 1 is equal to student 3? It returns false, because the default implementation of is equal to does not check the content. It is very similar to is. And if you would want is equal to to check the content, then we would need to implement it ourselves. So let's get back to the definition of the student class, and I'll define a constructor underscore init underscore self comma id colon self dot id is equal to id. In addition to this, we would want to define a method called underscore underscore equals. All these methods which are starting with underscore underscore are called under methods, or they are also called dunder methods, dunder. So let's define a dunder equals method. So the equals method takes two parameters. What is the current object? What is the other object we would want to compare against? Self comma other. And typically you would want to actually compare the type. So we would want to check if type of self is equal to other, or is instance of self comma super of other. You might also want to check the super class instance, but let's keep it very simple for now, and I'll return self.id. I'm only comparing the IDs. So I'm returning self.id is equal to other.id. So what would happen now? Let's redefine the instances. Student1 is equal to student of 1, student 2 is equal to student of 2. We said student 3 is equal to student of 1, and student 4 is equal to student 1. Is student 4 and student 1 equal? They are pointing to the same object, so they are definitely equal. Is student 2 is equal to student 1? False, because they have different IDs. However, let's see if student 3 is equal to student 1. It's returning true now, because we have now provided our own implementation of equals. This is one of the important things that you need to remember. So if you are defining a class and you'd want the equality for that class to be looking at the content of the class, then we would need to override the underscore equal method. We would need to override the dunder eq method. Once you override it, whenever you do a student 3 is equal to student 1, whenever you do a comparison between the objects using is equal to, the equals method would be called. In this quick step, we looked at how to implement a custom equals method for your classes. Until next step, bye bye.